Hi, everybody. My name is Khawaja Shams. I'm your host at the Cash It podcast. I'm here with Erik Peterson. He's the CTO and founder at CloudZero. Erik, welcome to the show.
Hey, thanks, Khawaja. It's great to be here.
We were having breakfast and you mentioned a phrase that I just have not been able to shake off. It's this idea of $1 million line of code. Can you tell me what $1 million line of code is?
That's when I knew we were going to have a great breakfast, when you kind of leaned in at that moment, and I was like, "Oh, this is going to be a fun conversation this morning." So it was born out of a really interesting observation that I had, which was that as you go in and try to do all these complicated things around cost savings, the realization actually was that a lot of times it comes down to one line of code. And a couple of customers that I had started working on early on, I started quizzing them, asking them, like, tell me about some of the things that you've done. And they were like, we found out when we finally had the ability to zero in on the part of our system that was costing as much as it was. We realized it was just one line of code that they moved out of the for loop, that they changed, and it didn't change the user experience at all, but it saved them $1 million over the year. So I became fascinated with that idea, and I started collecting this kind of virtual shoebox of $1 million lines of code. And when you leaned in on that, I was like, oh, we're going to have a deeper conversation about this.
I did lean into it because my sense, I mean, CloudZero is a company that helps people save on their cloud bills, right? And I always imagined the way it's being done is more of a accounting tool where it's giving you a prioritized list of your spend so you can go in. But just this idea of technically engaging with the developers just seemed fascinating. And then your shoebox and the examples you shared were fascinating. We'll get into those in a second, but let's start with what is cost engineering?
A lot of people think that saving money in the cloud is, the process of turning things off or doing stuff after the fact. And the reality is we're in a world where the engineers are the ones making the hard decisions, right? Every engineering decision is a buying decision. Is it as an engineer, you want to understand what's happening in the systems that you're building. When you sit down to create something, you're probably just trying to answer a question: can it even be done? And then once you answer that question, then you start to think, well, can I make it faster? Can I make it more resilient? Can I make it more available? Can I make it, more delightful for my customer? And for really anyone building in the cloud, the question that they should be adding to that list is, can I also make it more profitable?
Got it. It's quite difficult, right? Because for me, what I observe a lot when talking to customers at Momento is sometimes people have just really over provisioned their caching notes. And what I've observed is the engineer, when they're making the decision of whether to use a 2XL or an 8XL, there's enough layers of indirection between the engineer and the bill that the cost implication just doesn't register with a lot of engineers on, what a 2XL versus what an 8XL might do. And that's a very subtle situation where it is a buying decision, but the engineer is not making a buying decision from their perspective. They're just provisioning resources, and a bigger one is less likely to page them in the middle of the night. So how do you make sure that the engineers are becoming a little bit more conscientious?
We've already reached a point where nobody builds something that it just runs on one box. It's it's part of a big, vast network of little systems or microservices or however you thought about it. Even if you're still pursuing a monolith pattern, which is fine in some cases, it's still a lot of moving parts. And so for a while, we've been trying to pursue this world of traceability and observability. We just haven't incorporated cost tracing, is the way I like to think of it, into that equation. And to do that, you have to pull in a lot more information than just looking at the bill. Right? There's a lot of thinking around cost. And it's like, oh, you're just processing the bill. You're creating a fancy bar chart on top of the cost and usage report, right? And like engineers don't need that, right? What they want is some understanding about how these things are interconnected, and when they created that thing, what the downstream effects or upstream kind of, inputs were, so that they get a clear picture of what was, what's the source of the expense. If you take all that cost information and then you start to pull in telemetry about how those systems are being used, who's using them, when are they being used, by, what's the time of day, how how does that kind of flow through the system? Even using, some of the traceability information out there, and, connect all the data points in there. So application logs, load balancer logs, database transaction logs, pull that in and then correlate that with the spend. Now I can go from this customer at this time on this system, which is then connecting to this database, accessing these tables, accessing this query, are responsible for the cost, right? Let me go optimize that query. Let me go change my data access pattern. Let me go um, move that line of code, and it has dramatic effects, $1 million kind of effects for big systems.
Yeah, you consistently use the word cost optimization over cost reduction. I want to hear more about why you use the word optimization instead of saving. And does it always have to mean compromising the user experience at the cost of cost optimization?
I think you should always be optimizing for an excellent user experience. And I think cost savings as an exercise is not exactly a very exciting one, not exactly a business objective at all. Like your customer doesn't care about that. And I think just having that mental shift that you're thinking about there from a delight the customer perspective, is enough to, cause you to realize like maybe it's not, be all, maybe staying on an 8XL is fine or whatever, kind of system you're using is fine. It's it's as long as it's aligned with that kind of optimal user experience. And the outcome of this is that, ultimately you start to see the connections between, well, if I have built a more efficient or effective system, then I have more resources to invest in maybe a larger engineering team, maybe more functionality, maybe a different, mode of operating or building out my teams because it's all interrelated. And then you're going to deliver more value. The least delightful solution in the world is one that goes out of business and fails to make anybody happy.
It sounds like it's more of an engineering problem than it is a finance problem when you start thinking about infrastructure cost. But what I see over and over again is finance team thinking about cost and engineering teams thinking about building. Do you share that observation and why do you think that
Yeah.
is?
Well, it's something I call the flip. We talk a lot about the switch or the shift to cloud. And, from a finance or business perspective, you get in this mode of thinking about procurement. It's like, well, how do we buy better? Because that's what we used to do. I'm going to give that then to this engineering team and they're going to go do magical things with it. And, that's the world that that all of us really, honestly, we, kind of came from that. And meanwhile, so here we are watching all this stuff shift to cloud, but there's something else that happened, which is, this flip, which is everything prior to cloud, you know, BC cloud, before cloud, right?
Cloud BC.
Optimization was all about maximizing consumption of what resources were given to me. So if the business figured out how to go acquire, 20 servers, I better use those 20 servers. Otherwise I'm wasteful. After cloud AC, right? We're in this world where th- now optimization is about using the smallest amount of resources to accomplish the goal. Right? And as engineers, our training, our kind of mindset is we have to flip it. We have to completely flip the way that we think about this because we're almost like subconsciously trained to use everything that's been given to us. And that is why we get into these really expensive kind of mistakes.
In the BC era, adding more resources or consuming more resources had enough friction where you'd have to wait a while. So the temptation for impulse buying decisions was just not there. Whereas in a cloud world or in AC, there's enough resources available at your fingertips. You can buy a lot more, you can consume a lot more. Um, and I don't think that's always a bad thing, right? Like you could consume more and improve the user delight to cost dollars spent on infrastructure ratio. And that might be good for your business and add value to the business, like you said.
It's the greatest thing ever. This concept of elasticity is one of the greatest properties. The cloud era, modern engineering is your ability to use what you need in order to delight, right? The reality that we see in a lot of architectures is that this idea of elasticity is just still an idea. Even if we're doing some auto scaling things, a lot of people have only really figured out how to scale up. They haven't really figured out how to scale down. And these patterns get quite complex, and it's just hard to flip our minds into designing and building a different way. Because why shouldn't we be in a world where instead of telling my system how much RAM and CPU I need, I could also say, well, I also have a budget, and then it goes and figures out what the optimal way to like launch that workload is according to those parameters. The telecom industry understands quality of service, right? So these aren't foreign concepts. These are things that we need to start incorporating. And I tell a lot of engineers, like, if you're afraid of this thing called cost, like the money being spent, just treat it as a number. Remove the dollar sign next to it, right? And just treat it as a number. Big is bad, small is good, right? And you don't have to care about, the details of this. It's just another performance metric that should go into your equation when you're trying to build this system. And and I think that's a really powerful way to look at it, instead of, because all this stuff is abstract anyways.
Awesome. That's really profound. I do have one question before we end the show. Can you give me an example of a $1 million line of code?
Oh gosh, so many good ones, so many terrifying ones. I'll give you a couple examples. So the obvious ones are, a lot of times people forget about all of the interdependencies of the observability or monitoring systems they have in place, and they flip a switch in ops. Somebody goes and says, well, let's just turn on debug logging. And then they go from, a couple $100 being spent an hour to thousands of dollars being spent an hour, because now their engineers have done great, incorporating debug logging throughout their application, and they're suddenly producing what's going to be terabytes of data. And that becomes really expensive. And it's a single configuration change. Sometimes you just change it in a Terraform or a CloudFormation template, and boom, it's happening. And I see those all the time. The ones though that I think are more interesting are when you really get into it and you go, my favorites are a lot of them, the data access patterns that are out there. Most recent one I saw was a single line of code that, it came down to when they were building the system, that it was just easier to make this API call to S3 and to just say like, oh, how many files are here? What's the metadata that I can pull back? Let's just put that inside the for loop and make this call so that we don't have to store that in memory somewhere. Right.
Yep.
And this system, went from a prototype to full on production, running in the world, and then going from, growing to a point where they had tens of thousands, I think hundreds of thousands of customers hitting this system. And at that point, that little API called S3 is now, over the year, it's well over $1 million. And when they trace this down to that chunk of code, and they're like, geez, why is it this system costs so much? What's happening? I say, well, look at these billions of API calls this thing is making. They're like, that costs money? The files are so tiny. There's nothing where the bytes that are moving across the line, like there's nothing going on. They're like, yeah, every one of those API calls costs money. Like, I could just take this single line and move it outside the for loop, call it at the beginning of the thing, and change nothing about my software. Because these are configuration files. These aren't even data files that are changing constantly. Like I just moved it over here. And they did that. They deployed it, and it was like instantaneous. It was the fastest cost savings it's faster than having to go in and try to do something that I hate, which is, trying to right size or find the waste. They save more money in less time with that single line of code. That's the beautiful thing about these $1 million lines of code. So, it's things like that, particularly when they have zero impact on the user experience, where it turns people into believers and they go, oh my gosh. And the only reason people are struggling to find it is because, again, it's this big data problem. You have to connect all this information together to actually trace down to that piece of the system. But I'll tell you, Quadra, one of my takes the cake, honestly, super favorite stories is the one you told me over breakfast not too long ago when we were talking about DynamoDB. That one still is a soft, special place in my heart, about just shrinking the size of the response or the request, to get to fit it into the limit so you could get one request instead of two into the same thing.
Well, the dynamo boundary is your charge for the size of the object, and whether you're writing, 1 kilobyte or 100 bytes, you're charged for the whole kilobyte. So where it gets people is if you're writing 1 kilobyte and let's say 4 extra bytes, you're actually paying for 2 kilobytes. So we had a customer where they were able to just make a modification, one line of code to reduce the size so it goes beyond the boundary. It went from 1 kilobyte and 100 bytes, whatever, to below 1 kilobyte. And suddenly their dynamo write cost just halved, right? And the way they did it was they just changed the way they were writing the date. They were referencing the date in multiple locations, and they used a different method to express the date instead of as a string. And boom, dynamo bill halved, more read, more availability, and so forth. The S3 one is particularly exciting to me because in that scenario, I suspect they actually improve the user experience because they're not going back to making a network call every iteration of the for loop as well. So just love examples where you not only save cost, but you improve the user experience.
Yeah, the application got a little faster too in the process, right? It wasn't just saving money, but also slightly faster. And the part of the challenge was S3 was just so darn performant that it never rose to the top, and doing some of the things. It's like, gosh, this stuff was more poor, it was poorly engineered in the first place. So maybe would have like been more obvious, but yeah, it's these like little tiny things that I think are really fascinating. It's like you're playing that really interesting kind of emergent game of Tetris to fit the blocks. The DynamoDB write example, the do we need to access this data like a billion times a day instead of I'll just put the data in a variable and and reference it once. And it's so easy to miss those things. So the challenge has always been like discovering them, and that's the path that I'm so passionate about. I think a lot of people are, you could call it code golf, but I think all the functionality you could build and deliver instead of spending that money on that one line of code. Yeah, painful.
That's true. Eric, thank you so much for being here. I'm actually really looking forward to your talk at QCon SF. Looking forward to hearing more of these $1 million lines of code, and really appreciate you giving us a quick preview.
Yeah, thank you, Khawaja. Yeah, we're going to get into the details. We're going to look at some real examples. We're going to even look at the code a little bit, and I'm going to try to ask the audience, hey, can you spot the $1 million
Ooh,
sitting in this code? It's going to be a fantastic time in San Francisco.
that's awesome. Thank you for your time, Eric. See you.
Awesome. Thanks, Khawaja. Take care.